For any assignment-related queries, call us at +1 678 648 4277. You can mail us at support@solidworksandmenthelp.com or reach us at https://www.solidworksassignmenthelp.com. Energy methods in elasticity problem 1. Consider an elastic cantilever beam loaded at its tip. A. Specify the boundary conditions. B. Derive the load-tip displacement relation using 4 methods presented in class. Method I. Solving uncoupled problems. Method 2. Solving coupled problem, direct integration. Method 3. Castigliano theorem. Method 4. Ritz method. SolidWorksAssignmentHelp.com. Solution 1. A. Boundary conditions W 0 equals 0 W 0 equals 0. B. Derive the load-tip displacement relation using 4 methods. 1. Solving second-order uncoupled problems, we will use moment curvature relationship, curvature displacement relationship to solve the problem. These relationships combine to give, we need the moment. Find reactions. SolidWorksAssignmentHelp.com. Find moment in beam base on force balance and moment balance. SolidWorksAssignmentHelp.com. Combing the above results from force balance and moment balance. Integrate moment once. M equals PL plus PX. SolidWorksAssignmentHelp.com. Use BC. Integrate once. Use BC. SolidWorksAssignmentHelp.com. 2. Solve coupled problems using 4th-order direct integration. We use the 4th-order differentiated equation, and we need 4 boundary conditions. Integrate and use boundary conditions to determine the constants. Use BC. SolidWorksAssignmentHelp.com. We get then. Use BC. We get then. SolidWorksAssignmentHelp.com. Use BC. We get finally. 3. Castigliano theorem. Find moment in beam. SolidWorksAssignmentHelp.com. Calculate strain energy. Use Castigliano theorem. SolidWorksAssignmentHelp.com. 4. Ritz method. Assume shape function. Use SolidWorks.com. Find total potential energy. Minimize 3. SolidWorksAssignmentHelp.com. Solve for C1 and C2 using the above 2 equations. Finally, note, we obtain the exact solution with if we were to assume shape function of lower order, we can only obtain an approximate solution. SolidWorksAssignmentHelp.com. Problem 2. Consider a beam of length L and bending rigidity EI which is fully clamped on both ends shown in Figure 1. The beam is subjected to a point force P at the midspan. Solve the problem. Find the expression between the load and the deflection under the load using A. The direct integration of beam equation with the suitable boundary conditions, exact solution. B. The Ritz method, approximate solution. C. Compare the results and calculate the relative error of the Ritz method. SolidWorksAssignmentHelp.com. Solution 2. Solve for half the beam. Boundary conditions are SolidWorksAssignmentHelp.com. A. Direct integration. We use the 4th-order differentiated equation, where Q equals 0. Integrate once. Use BC. 4. We have by integration. SolidWorksAssignmentHelp.com. Use BC. 2. We have use BC. 3. Integrate once. SolidWorksAssignmentHelp.com. Use BC. 1. Midspan deflection. B. Ritz method. Solidworks assignmenthelp.com. Assume shape function. Boundary conditions are: use BC 5 and 6. Solidworks assignmenthelp.com. Apply BC 7 and 8. Combine the above two equations, we can solve for. Solidworks assignmenthelp.com. Calculate U equals W. Minimize. Finally. Solidworks assignmenthelp.com. C. Compare Ritz method and exact solution. Because we guessed the correct order of the shape function, we got the exact solution. Percent error equals 0. Problem 3. Use Castigliano's theorem to calculate the horizontal deflection at point D in figure. Solidworks assignmenthelp.com. Solution 3. Find reaction. Where in RxMR are reaction force and reaction moment, find internal moment. Distribution at each section. Solidworks assignmenthelp.com. Section AB. Section BC. Section CD. Calculate strain energy. Solidworks assignmenthelp.com. Use Castigliano. Solidworks assignmenthelp.com.